All right, another projectile motion example. This one's a little bit different in that this stone is thrown downwards, not straight down, but downwards at an angle, and they give us this angle of 40 degrees with the face of the cliff. So this 40 degrees is right here. We're told the cliff is 75 meters high. Now again, we do need to recognize that this stone is not going to travel in a straight line. That vector is drawn rather long for the picture. The stone, as soon as it leaves, gravity starts taking over, and so its motion is a portion of a parabola. It's not straight line motion. This is what makes it two-dimensional motion, meaning we need to break our problem into parts, into components, where we are accounting for position, velocity, and acceleration in both x and y directions. We can use the kinematic equations because we are assuming no air resistance. Even though the problem doesn't specifically state no air resistance, we are assuming no air resistance. And then we do know there is an acceleration downwards at 9.8 meters per second squared. This is why we can assume constant acceleration and use our kinematic equations, also called the big three on the test notes. When I solve a problem, I do not typically write out all three equations. I'm just writing them out here to talk about them. The approach. First, like I mentioned already, we need to recognize that this stone is not going to travel in a straight line, which is why we need to look at x components and y components. What happens horizontally and what happens vertically, they're independent of each other. They do show the same time, of course, but other than that, that's what they have in common. We need to choose an origin. I'm going to go ahead and make ground level right below where the stone is released, my origin, so that makes my initial x position 0, and my initial y position will be the height of the cliff. Final position, again, we're finding that horizontal distance that the stone has traveled, how far away from the base of the cliff the stone will land. My choice of origin makes y final 0. We could put the origin at the top, and then the final y position would be negative 75. There's nothing wrong with that. This is just your choice. But you do need to assign the positive and negative signs correctly based off of where you have chosen your origin. This initial velocity, we need to find the components. I'm going to move this to the side a little bit so I can draw my vector that represents 25 meters per second. We do know it to 3 sig figs. I'm just not writing out the 0. I will take into account that 0, though, when I write out my final answers. So we have a y component of velocity initial that points downwards, and an x component of velocity initially that points to the right. This x component, it is opposite the 40 degrees. And so the x component is going to be found using sine. The sine of 40 is the x component over the hypotenuse. So the x component will be 25 sine of 40 degrees. always highly recommend drawing your triangle out so that you are making sense of sine versus cosine and the sides, the values that you know. I'm keeping out a couple digits beyond what we have significant figures for, just to minimize rounding errors. In the y direction, we're adjacent to the 40 degrees. So this is going to end up being the 25 cosine 40. But again, it's downwards, so we do need to put a negative sign on there. So 25 cosine 40 gives me 19.1511. The negative sign is important because it's representing that this stone is headed downwards initially, and that will come into play in finding the time. V final x is the same as it is originally because we're assuming no air resistance. So this is very similar to the previous example in terms of what we know, what we're looking for. It's different in terms of finding these components and making sure we're accounting for this stone headed downwards initially. Total side note, we can swap up what information is given. For example, we could give time and ask for how tall the cliff was. We could give a final y velocity and also find time or how high the cliff is. So we can mix up what is given versus what is being looked for. We want to find x, and similar to the previous problem, this horizontal distance x coming from this middle equation, we've defined s initial to be 0. There is an x velocity initially. There's some amount of time it takes to get to the ground. But again, there's no acceleration in the x direction, so that third term in the equation disappears. It goes to 0. So to solve for x, we will need to find the time. When we set up the middle equation, or I should say, if we set up the middle equation for y, we end up needing to solve the quadratic formula to find time. Totally valid, totally doable. But again, I sometimes am not confident in my ability to remember the quadratic formula, and that is not in the test notes. So I just want to show you there is another way to get to time if you do not happen to remember the quadratic formula. In terms of the y direction, this third equation does not have time in it. I know delta S for the y direction, I know A, I know the initial velocity, so I can use this third equation to find Vy final. I'm going to come over to the far left and start setting up. This third equation, I'm putting my subscripts of y on. And then delta S becomes the final y position minus the initial y position. Vy final, remember when we take the square root of anything? The answer can be positive or negative of that, right? If I square positive 2, I get 4. If I square negative 2, I still get 4. So we do need to keep in mind the plus and minus sign. Vy initial, we've already calculated. That will be squared. Acceleration in the y direction, negative 9.8. Again, negative meaning downwards. Y final is 0 based off of my choice of origin. So numerically, I get plus or minus 42.8575. And the units will be meters per second. In this case, we have to choose whether the positive or negative sign is appropriate. Vy final means the y component of the velocity right before the stone hits the ground. It still totally has an x component as well, but here we're looking specifically at the y components. Well, the ball, or stone rather, is definitely heading downwards, and so we need the negative answer here. To find time, I'm now going to come to the top equation, and I can say Vy final is equal to Vy initial plus the acceleration in the y direction times the time. Time, when I bring Vy initial to the other side and then divide by Ay, it is important to have the negative sign on our Vy final because we will get a different answer if we do not. So again, positive and negative signs are describing direction. So negative for downwards. So plugging this through, I'm finding our time to be 2.419 seconds. So we still got to time just fine. We did not need to use the quadratic formula, though setting up the middle equation and solving the quadratic formula would be perfectly valid as well. So one is not necessarily any better than the other. This is just a choice on your part. So now to answer part A, I'm going to come back. I know the horizontal distance traveled depends upon this initial velocity in the x direction, which we've already calculated back when we were setting up the vector, the little right triangle that represents that velocity vector. We now have time, and so we can solve for that horizontal distance that has been traveled. I'm going to write our answer. We have three significant figures. The 25.0 is 3, the 40.0 is 3, 75.0 is 3. So 38.9 is what this rounds to. So this is our answer to part A. This stone hits the ground just under 40 meters from the edge of the cliff. This, of course, assumes, as shown in the picture, that the ground is horizontal. Part B, how fast is the stone moving just before it hits the ground? Well, we know that in the x direction it's traveling at this 16.0697 meters per second. But we also know that it's headed downwards at 42.875, or sorry, 8575. So if we were to represent that down here at the bottom, there's a horizontal velocity and a vertical downward velocity. When it's asking how fast the stone is moving, it means overall the total speed, not just in the y direction, not just in the x, overall, totally. So that final speed is always calculated by the Pythagorean theorem, knowing the x and y components. So we know Vx final, we know Vy final. So plugging that in, let me try that again. Square root 16. So 3 sig figs, I'm getting 45.8 meters per second. So this is our answer to part B, how fast it's moving just before it hits the ground. So as you're going through problems, look for the approach, not the final answers. Again, these last couple problems have been similar in that they're asking for that horizontal distance, and we found time through y. But we could be given different information. We could be given time. We could be asked for how high the cliff was. We could be given a final velocity and asked for time or how high the cliff is. So the most important part is to watch for the approach, the setup, how we approach a problem, as opposed to just the final equations we're plugging in.